All right, today we're talking about section 8.4, angles of elevation and depression. And I want to talk briefly about what these are and how to recognize them. Let's say I'm standing on the ground and I'm looking up, okay? I make an angle with the ground, horizontal, and my line of sight, right here, and this is, since I'm looking up, the angle of elevation, okay? Now, on the other side of this, let's say I'm looking up at somebody who's standing in a tower. Okay, so here they are, found my tower, and this person over here, Rapunzel, whoever you want it to be, is looking down. Okay, now their angle, let me move this angle of elevation and depression out of the way so I can finish my picture. This person, Rapunzel, is looking down based on the horizon up here. So this angle is my angle of depression. Now notice that my horizon is parallel to my ground, okay, or my line of sight. So that would make my angle of elevation and my angle of depression congruent. They're alternate interior angles. So really they're the same thing, but do you see that I just created myself a triangle? And this is a right triangle. So almost always I'm going to identify the angle they're asking about and then use the angle of elevation that's in the triangle. All right, so let's look at a couple of examples. It's going to be incredibly important that we identify which trig ratio to use in each situation, just like we were doing in section 8.3. Okay. All right, so your first problem, if you look at your notes, says, from the top of a tower, the angle of depression to a stake on the ground is 72 degrees. The top of the tower is 80 feet above the ground, and we want to know how far the stake is from the top of the tower. So where do I put all this information? Well, I'm going to add a little bit to my picture. I've got my stake on the ground right here that's holding in whatever it's holding, the angle, and the angle of depression, so from the top of the tower looking down, this angle right here is 72 degrees. Well, that angle is not in my picture, so I'm going to get it into my triangle using the alternate interior angle and call this 72 degrees. It goes on to tell me that the tower is 80 feet above the ground, the top is, so that means that this height is 80 feet. The question, do I want to know my hypotenuse or do I want to know my adjacent side here? And it says, how far is the stake from the top of the tower? So I want to go from this point right here where my stake is to the top of the tower. So we're looking for my hypotenuse. So now that I've got this figured out, everything's going to be based off of my 72 degrees that's in the triangle. That would make my hypotenuse and my opposite side. So going back to SOHCAHTOA, I want to use O and H. So we're going to use sine, and we're going to identify this as sine of 72 is equal to 80 over x. Remember that shortcut we talked about earlier. If x is on the bottom, it switches with sine of 72. So in my calculator, we would be typing x equals 80 divided by sine of 72. Make sure your calculator is still in degrees. If you didn't reset it, it should still be there from when you did it yesterday. All right, so my answer for this particular problem, I'm going to get a decimal. We'll round to the nearest tenth for this one. It doesn't specify, but we're going to get about 84.1 feet as my answer. Let's go on to the next problem. Okay, and I've got an elaborate picture. Your picture doesn't have to be this elaborate. You can draw a little stick house, a little stick ladder, or just draw yourself a right triangle. In this question, it says a ladder leaning against a house makes an angle of 60 degrees with the ground. So they haven't even said the word elevation or depression. They just said that this ladder, which is this guy part right here, makes an angle with the ground of 60 degrees. So this is 60 degrees. The foot of the ladder is 7 feet, so the foot is the base of the ladder, and it is 7 feet away from the foundation of the house over here. So that means that my bottom side of this triangle is 7 feet. Okay, so now what? How long is the ladder? So again, we're going to put x for my hypotenuse. All right, so 60 degrees. I've now got my adjacent side and my hypotenuse. So adjacent and hypotenuse is cosine. So we're going to say cosine of 60 is equal to 7 divided by x. And again, switch that, and we're going to type in our calculator 7 divided by cosine of 60. And you're going to get an answer of 14. Now remember, it said our units were feet. So our answer is 14 feet. Okay, let's look at the next picture. We've got a tree, a rather large tree. Okay, it's an 80-foot tree that casts a shadow that is 68 feet long. All right, so we know that this is 80 feet, and its shadow, which is down here on the ground, is 68 feet long. Okay, we want to find the measure of the angle of elevation to the sun. Well, think about where the sun is going to be. My sun should be coming from the top of my tree. So we're actually looking down here. Well, angle of elevation always has to come from looking up. So my angle of elevation is down here, looking up at the sun. So let's go ahead and solve this problem. Based on x, my angle, I've got my adjacent side and my opposite side. So now we're switching to tangent. So we've got the tangent of my angle, x, is equal to my opposite 80 divided by my adjacent 68. Remember when we spoke about finding angles, you want to use that blue button on your calculator second. So to figure this out, it's going to be typed in as tangent to the -1, the inverse of tangent, and just type in your ratio 80 divided by 68. We're going to get an angle measure that's a decimal, again, of 49.6 degrees. So this is my angle measure by angle of elevation looking up at the sun. Remember again, to get tangent -1, you're going to type second tan. All right, why don't you try this one on your own? I'll give you a few minutes, or you pause it, give yourself as much time as you need, and we'll see if we come up with the same markings to label this one. All right, so we've got a fire sighted from the top of the Ranger's Tower. So I'm looking at it from up here, looking at it down. It's got an angle of depression of 22 degrees. So looking at it from down here, we've got 22 degrees, meaning my angle of elevation is also 22 degrees. Hopefully, you guys have this labeled the same way I do. We also know that the tower is 75 meters tall. And I want to know how far the fire is from the base of the tower. Okay, so now pause it again and see if you can figure out the value of x, round to the nearest tenth. All right, so did you use tangent? Tangent of 22 is equal to 75 over x. Plugging that in your calculator, you should get an answer of 185.6. And this time we want to make sure we're consistent. We're talking about meters. Okay. Look at the next one. This is the last problem. And this one's always tricky for me to try to even visualize what's going on in the picture. So we've got the picture here. I've got my searchlight, which I'm thinking more along the lines of, I know this looks like a searchlight for a light ship or a lighthouse, but I'm picturing more of like a car dealership light source where they've got the light shining up so they can get your attention in the sky. Either way, the point of this is, what does it look like as a right triangle? So a searchlight is located 200 meters from an office. So this distance from here to here, let me see if I can get this up a little higher, is 200 meters. It's turned on during a cloudy day. The rays of the light hit the clouds directly above it, so we're talking about going straight up and hitting this cloud right here, directly above it, and we have an angle of elevation from the office to the clouds here we are, angle of elevation of, they tell us 35 degrees. The question is, how high are the clouds? So I want to know, how high above my spotlight or my searchlight are these clouds from the ground? All right, go ahead and see if you guys can solve this, set it up, figure out your trig ratio that you're going to use. You should have picked tangent. Tangent of 35 is equal to x over 200. And your value of x, the height of the clouds, is about 140 meters or 140.04 meters high. All right, we will work on this some more in class. There's no challenge question today. We are completely done with chapter 8, angles of elevation and depression, just more practice of your trig ratios.